everybody. Welcome to our second series in the theory of Bitcoin. If you are new to the channel, we are currently on Unit 2 of the Saylor Academy course, which is introducing us to Python. For those of us that have already put in the 17 hours in our first series, this is basically revision and our first step to getting certified. I'm here on the Replit website, so I just want to show you how we can get back in. So we just go to Profile, and then don't forget we're working on Python with Prybar so that we can use the console here on the right. Let me just close that. So I would like to use it. All right, so we need to click on, if you look over here, Python with Prybar, then we just click on Use Template. And then we need to click on Run. Then it's going to do, well, it's going to load it. And now you see we can work in our console. So if you go to Unit 1 of Series 2, our first video, you'll get the link to get Python with Prybar. You're going to need that to follow along with the Saylor exercises, but also the description here of how to use this console is actually, it's not updated. So you're going to need that link, otherwise you are going to get stuck. Today we are working on Unit 2. There are 10 units in total to do our revision in basically the basics, and then we will do our final exam to get our first certificate. I trust that if you did do Unit 1, you've done the exercise for the test. And those tests are also going to be useful as we get closer to writing our exam paper. So in this unit, we're going to look at Python arithmetic operators, relational operators, logical operations, and the Bool data type. We are going to explain operator precedence, and we're going to construct programs that apply variable types, operators, and operator precedence. Our programming journey begins by phrasing basic Python operations found on a common calculator, like plus, minus, times, divide, using the syntax of our programming language Python. So a plus is, as we know it, plus, and minus also, but when it comes to multiplication, we use a star. And when it comes to division, we use a forward slash. And you see that if we enter those calculations in our console, we will get the answer to these calculations using the correct syntax. So 3 out of 4. Now notice here we've used 1 forward slash. If we use 2 forward slashes, because 0.75 is a float number or float type, then we can, by using 2 forward slashes for division, we ensure that we only get an integer type. So the answer is 0. By hitting the enter key after entering each command, you can convince yourself that you know how to use Python to add, subtract, multiply, and divide. The numbers 3 and 4 are referred to as operands, and the plus, minus, times, divide signs are referred to as operators. More specifically, they are arithmetic operators because they are used for arithmetic. As we progress in this unit, other types of operators will be introduced. So we're going to learn about all the types of operators in Python. We also have operators like here we have 2 stars, and this is basically to create an exponent. So if we want to say 2 to the power of 2, which is 4, we use 2 stars instead of 1 star because 1 star is just for multiplication. Exponents can also be fractional. So for example, by using a fraction, so for example, 16 to the power of half, which is the same as 1, half is the same as 1 divided by 2, we can actually work out the square root. So if we say 16 to the power of a half, or 1 divided by 2, we get the square root of 16, which is 4. And in the same manner, we can also work out the cube roots. So instead of saying to the power of half, you would say to the power of a third, or 1 divided by 3. So in this case, the cube root of 8 is 2. While these operators are useful for operating on numbers, programming applications require their use with variables. So in this example, instead of just putting numbers like we've done up here, we create variables. And we assign a value to that variable using the equals operator. So in this case, we're saying A is 3 and B is 4. So now when we want to do like arithmetic operations, now we can just say A plus B. We can say A minus B. We can say A times B, A divided by B, and so on. And so what that means is we can change A or B when we define it as a variable, but it won't actually affect the calculation itself because it's always going to take A and it's going to plus B, or it's going to minus B. So and you can do this yourself in the console, when we press the run button and observe the output in the command line window, observe how the assignment operator equals can be used to update, change, and overwrite a value contained within a variable. So over here we see initially A was 3 and B was 4, but later on we can change A to 2 and B to 5. So now if we print C, it will work out 2 plus 5 instead of 3 plus 4. Also pay close attention to the data type generated by each calculation. Generally, the variables A and B are of the type int. However, if the calculation results in a value that involves a decimal point, Python converts the results to the data type float. For the example above, C equals A plus B results in a variable of type int, while C equals A divided by B overwrites a previous value, which was integer, and updates C to a variable type float. So remember, if we say A plus B, right, which is 3 plus 4, which is 7, that's an integer. There's no decimal point. So C effectively, because we're keeping C the same here, we're just printing out the different outputs. C becomes or remains an integer. But the moment we say C equals A divided by B, and we get a decimal number, then it becomes a float. And so C is no longer an integer type, but a float type. Lastly, we introduce two more operators, the percentage and the two forward slashes, that often prove useful for working with integers. So the modulo operator, which is basically the percentage symbol, it works out the remainder after dividing two integers, for example, a percentage b. And the two forward slashes enter the division that gives an integer result by taking the floor of the quotient, for example, a divided by b. So let's copy this into our Replit. And then I'm going to run the code. So we are printing, whatever we print is going to appear here in the console, a string which says the remainder of, and then within that we want to print x and y, whatever the values may be, we can change them, equals, and then z1 is basically x percentage y. So I will tell you how we get to the answer 5, just to explain the modulo operator. So we want to say 19 divided by 7. So we know 7, 14, 21. 7 is not going to go into 19 without there being a decimal. So it's going to be an integer result. What the modulo operator does is it will say, for example, 7 can go into 19 two times, a whole 2 times, so 740. So all we do then is we subtract the difference. So we say 19 minus 14, and we get the answer 5. So we'll see, and we've actually already seen it in our earlier videos, where that's quite useful for singling out even or odd numbers. And, there might be practical use cases for that. But for instance, anything divided by 2 is an even number. So when we get to Booleans, if a remainder is returned using, like, for example, the modulo operator, then it means it's not an even number. Now, if we say 19 divided by 7, right, we know that, again, we're going to get a percentage or a decimal. So what the two forward slashes does is it ensures that it basically rounds it off. So 17 can go in 2 times, and instead of saying 2 comma or 2 point dot dot dot, it just keeps it as an integer so that the number doesn't convert to a float. So we can do some practice. Numbers are extremely common in programming. They are used to represent things like screen size, dimensions, geographic locations, money, and points. The amount of time that passes in a video, positions of game avatars, and colors through assigning numeric codes, and even for Bitcoin. Being able to effectively perform mathematical operations in programming is an important skill to develop because of how frequently you'll be working with numbers. Though a high-level understanding of mathematics can certainly help you become a better programmer, it is not a prerequisite. If you don't have a background in mathematics, try to think of math as a tool to accomplish what you would like to achieve and as a way to improve your logical thinking. We'll be working with two of Python's most used numeric data types, which is integers and floats. Then there is a video here which goes over operators that can be used with number data types in Python. And just out of curiosity, I just want to check out the video. So this is our revision class, and I feel like it just basically explains everything I've explained, which is addition, subtraction, multiplication, the modulo operator, and so on. Let's take a look though at operator precedence. In Python, as in mathematics, we need to keep in mind that operators will be evaluated in order of precedence, not from left to right or right to left. So if we look at the following expression, 10 plus 10 times 5. So remember with basic maths, we also have order of operations, which is you will do your brackets first or your multiplication and your division, and generally your pluses and your minuses happen last. Otherwise, what will happen is you will get a different answer. So if we just read this from left to right, 10 plus 10 is 20. If we say 20 times 5, which is 100, then that is actually not the correct result. The correct result would be 10 times 5, which is 50, plus 10, which is 60. The nice thing about Python is it follows order of operations that we know in maths. So the output here is 60. We may read it left to right, but remember that multiplication will be done first. This is because 10 times 50 evaluates to 50, and then we add 10 to return 60 as the final result. If you want to do the 10 plus 10 first, you would have to put it in brackets. Even then the answer, yeah, so we would say 10 plus 10, which is 20, and then times it by 5, but you have to put in the brackets if you're wanting that to be done first. So they have here the acronym PEMDAS. I know BODMAS. Basically, it's your parentheses, which is your brackets. Those always get done first. Then your exponents, which is anything to the power of something else. Then it's your multiplication. Then it's your division. And lastly is addition and subtraction. Whatever acronym works best for you, try to keep it in mind when performing math operations in Python so that the results you expect are returned. Then we know about the equal assignment operator, which is used to assign a value to a variable. And we also know about variable names, about using descriptive variable names and also the values. Sorry, the rules. So we covered that in Unit 1. But there are some other assignment operators, so let's have a look at them quickly. The most common assignment operator is one that you have already used, the equal sign. The equals assignment operator assigns the value on the right of the variable to a variable on the left. For example, v equals 23 assigns the value of integer 23 to the variable v. When programming, it is common to use compound assignment operators. Sorry. It's just something blocking my screen. When programming, it is common to use compound assignment operators that perform an operation on a variable's value and then assign the resulting u value to that variable. These compound operators combine an arithmetic operator with the equal operator. So for an addition, we'll combine plus with equals to get the compound operator plus equals. Let's see what this looks like. So we have created a variable called w, which basically is the value 5. We use plus equals to basically keep adding 1 to 5. So plus equals 1. So our output will be 6 because we've added 1 to 6. First, we get the variable w equals to the value of 5. Then we use plus equal assignment operator to add the right number to the value of the left variable, and then we assign the result to W. Compound assignment operators are used frequently in the case of for loops, which you'll use when you want to repeat a process several times. Again, we have already covered that on this channel in our first series. So this is our for loop. While, or basically for x in the range 0 to 7, so the numbers 0 to 7, we are going to times x by 2. So for as long as x is within this range, we're going to keep timesing it by 2 to get our result for x. Remember, when we work with range, it's inclusive of the first element or the first number and exclusive of the last. So in this case, we're only going to times x by 2 up until 6. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and so on. And notice here how it ends at 12, which is 6 times 2. So we've looked at plus equals to keep adding a specific number. We can do the same with times equal, minus equal, and even divide equal, all of the operators that we know. Compound assignment operators can be useful when things need to be incrementally increased or decreased, or when you need to automate certain processes in your program. So we can now mark this section, which is 2.1, as complete. So we will now move on to, just want to see here, next page. Oh, I see there's more here. So we know that x plus y is the sum. A lot of this is just a bit of repetition. Here's some addition. Remember that integers can be both positive and negative numbers, even 0. We can do the same with floating numbers. Unary arithmetic operations. So a unary arithmetic operation or mathematical expression consists of only one component or element. And in Python, the plus and minus signs can be used as single elements paired with a value to return the value's identity, plus or change the sign of the value, minus. Though not commonly used, the plus sign indicates the identity of the value. We can use the plus sign with positive values. So let's read on. So I equals 3.3 or 3.3. So remember, this is a decimal. We want to print I, but now we've said plus. So our output will be 3.3. When we use the plus sign with a negative value, it will also return the identity of that value, and in this case, it would be a negative value. So j equals negative 19, print j, but remember we put plus, so it's going to print negative 19. Let's try that out in our console. So I equals negative 1. If we say print plus I, it will print negative 1. If we just say print I, it still prints negative 1. not quite understanding the purpose of this. With a negative value, the plus sign returns the same negative value. The minus sign alternatively changes the sign of a value. So when we pass a positive value, we'll find that the minus sign before the value will return a negative value. So in this case, I is 3.3, and we want to print I, but we want it to have a negative value. So it will output negative 3.3. Alternatively, when we use the minus sign unary operator with a negative value, a positive value will be returned. So in this case, j is negative 19, and we want to print negative j will actually become positive. So this is something I learned in maths at school, which is whenever, for example, you multiply two negative numbers, it becomes positive. So just think of it that way. Two negatives make a positive. I can probably see how this is useful when we're looking for outputs. If you maybe there's a certain calculation that you're looking to do, and you would like it to work out for purposes of your calculation, the output of a certain value needs to be negative. Because remember, Python will still, if you add a positive and a negative, it will still perform the correct calculation. So for example, 4 plus negative 3, 4 plus negative 3 will give us 1. Okay, so a plus and a minus becomes a minus. If we say 4 minus negative 3, we get 7. So remember, a negative and a negative will produce a positive. So it doesn't matter if you're minusing or you are timesing, the negative and the negative becomes positive. So negative 4 times negative 4 will give us a positive 16. So the way I'm seeing it, why this is probably used in practice, specifically the negative, because plus, we know a plus and a plus is going to be positive. So, and even a plus and a negative, right? So you probably, because of here where we're subtracting, we probably will want to, in a situation, rely on using a sum. And so this unary operation comes in handy to avoid incorrect incorrect calculation. The unary arithmetic operations indicated by the plus sign and minus sign will return either the value's identity in the case of plus or the opposite sign of the value, as in negative I. So remember, 3.3 here became negative. And it says here the plus sign basically just indicates the value, but it's not commonly used because it didn't really change the output. Here it stays positive and here it stays negative because a plus and a negative will yield a negative result. Let's go to our next page. So multiplication and division, we know how to do that. We've got our star and then our / for division. It explains here a difference between Python 2 and 3. For purposes of Bitcoin, we're focusing on 3. Now, if you look at this question here, m is 80 and n is 5. And if we say 80 divided by 5, we're going to get the answer 16. But notice how it gives us a float number, so 16.0. So it says here that this is one of the major changes between Python 2 and Python 3. Python 3's approach provides a fractional answer so that when you use 1// to divide 11 by 2, the quotient is 5.5 will be returned. Whereas in Python 2, it would return basically the rounded value or the nearest whole value, which is 5. Python 2's operator or division operator performs floor division, where for the quotient x, the number returned is the largest integer less than or equal to x. Basically, what we do in Python 3 is we use 2 / to perform floor division to get the nearest whole division value. And that's when you want the quotient to be in whole numbers, or an integer, not a decimal. The modular operator I have explained. Power, we also know. So it's 2 multiplication signs or 2 stars. And then we've covered operator precedence, so PEMDAS or BODMAS. This is basically just an abbreviation for you to help you remember the order of operations. And then our assignment operators. So we've learned about plus equals. It could be 5, it could be 1. Same applies to all the operators we've just learned about, especially when you want to, here it says that they are frequently used in the case of for loops, where you want to repeat the process several times. So now we're going to learn a bit more about PEMDAS. I personally know it as BODMAS. So when we look at PEMDAS and these 2 examples here, we have the brackets, which remember was to calculate the square root. And then we have this example here, which actually sort of looks different. So here we know we're going to do 1 divided by 3 first, because brackets are always first. Whereas here it can simply read from left to right, because it's basically actually not. The exponents is before any division will take place, so it will work out 8 to the power of 1 first before it divides by 3. You should recognize the first instruction from the previous section. Observe that these instructions yield 2 totally different answers. So let's test it out. So if we run, we should get, oh, you know what, let's write it here in our console, because I'm not going to print it. Or we can just say print here, okay, so that it goes into the console. Prints, don't forget your brackets. Let's run it. And you see how we get 2 and 2,6666 and so on. The reason is that there is an order in which the operators are evaluated. The order of operations and operator precedence define how arithmetic calculations are to be evaluated. As expected from basic arithmetic, exponentiation takes place before multiplication and division, which take place before addition and subtraction. So remember PEDMA. First it's your P for parenthesis, which is basically a fancy word for brackets, and then it's your exponents, then it's your multiplication and division. As an example, consider the expression 8 to the power of 1 divided by 3. As shown above, in this case, exponentiation taking precedence over division means that 8 to the power of 1 is computed first to obtain a value of 8, and then that result is divided by 3. Hence, the final result is 2.666. Notice that when parentheses are added around the exponent to form 8 to the power of a third, the exponent evaluates to 1 over 3, and the cube root of 8 is completed. The term inside the parenthesis has higher precedence and takes place before exponentiating. This should be a refresher about the order arithmetic expressions are evaluated in. So I see here we have a video on order of operations. Let me just zoom out here. So I'm zooming in to try and also just make it easier for you guys. If maths is something you struggled with or you probably didn't do or you're not familiar with, then it's a good idea to watch these videos. We are going to move on and mark this section as complete. So practice with operator precedence. And I'm going to zoom in some more. So hopefully you guys can see better. Now we will consider order precedence when operations are phrased within the Python programming language. Before running this set of instructions in the run window, try to predict the value each variable will contain. So in if, we've got a plus b minus c times d plus e divided by d. So I'm going to do the first example. We're going to start with, first of all, there's no brackets, so we don't need to worry about brackets, and there's no exponents, but there is multiplication and division, which means we're going to start with c times d, and we're also going to look at e divided by d before we look at these pluses and minuses. Remember, we're not going to say d plus e because next to these is division and multiplication, and those come first. So c times d is 5. It's basically 1 times 5. And e, which is 3 divided by d, so we're looking at 3 divided by 4. We can do a quick calculation here. And 3 divided by 4. And let's run our code. And we get 0.75. Now, if we look at this example, or this question, now we've only got pluses and minuses left. So we can now start to work from left to right. So a plus b is 3 plus 4, which is 7. 7 minus c. C is 1. So that answer, sorry, not minus c because we said c times d. So we say 7 minus our answer, which was 5. C times d is 5. So 7 minus 5 is 2. And then we're going to plus our answer of e divided by d. And that would mean that we are saying 2 plus 0.75. So we should get the answer 2.75. And we are going to test that in our Replit. So I'm going to copy all of that code, and then I'm going to say printf. And let's see if we were correct. So we get 2.6. So let's say Print E divided by D. Maybe there's something not right there. Print E divided by D is 0.6. So that's why it's 2.6. Because our final result up until here was 2, and E divided by D is 0.6. So 2 plus 0.6 equals 2.6. In the next example, we would start with the brackets first. So even though this is actually plus, it's within brackets, so we start with D plus E. Then interestingly here we've got times on the one side and division on the other side. So once we've got this result, we can take it and times it by C, divide it by D, and then look at A plus B minus the result that we get over here. It is important to note that 2 forward slashes and the percentage sign are considered division operations, and because of that have precedence equal to multiplication and division. So try not to get confused here by this example, but you see how we've got exponents, so that will be first. Okay. Remember, exponents take precedence over division, and what they're telling us is that the 2 forward slashes and the percentage have the same weight as or precedence as multiplication or division. So we would work out the exponent first, and only then will that answer be divided by x. And in that answer, we would work out the modulo. We would use the modulo operator to work out the remainder. So that's one section of the sum. Now we've got a plus. But before we look at the plus, we're not just going to say plus y, because next to the y is the modulo operator. So it looks like we have to do this section first. And they are all basically division and multiplication. So we work out this half, and then the answer of this half and the answer of this half, we add to get our final answer of A. Useful guiding principle when writing code is, if the order precedence is not clear to you by looking at the expression, use parentheses or brackets to make things obvious, since parentheses always takes the highest precedence. When an expression contains more than one operator, the order of evaluation depends on the order of operations. For mathematical operators, Python follows mathematical convention. The acronym PEDMAS is a useful way to remember the rules. So just to sum up, parentheses or brackets have the highest precedence. So if you want the plus to be done first, where normally it takes lowest precedence, you must insert your brackets. Exponentiation has the next highest precedence. So 1 plus 2 to the power of 3 is 9, not 27, because we first calculate 2 to the power of 3, and then we add 1. Multiplication and division have higher precedence than addition and subtraction. So if we look at this sum, we're going to calculate 2 times 3 first before we minus 1. Operators with the same precedence are evaluated from left to right, except for exponentiation. So in the expression degrees divided by 2 times pi, the division happens first and the result is multiplied by pi. Okay, so that's it. That's kind of what we did here, where with division and multiplication, doesn't matter what part you start with. You can just read left to right. And the same with plus and minus. So you're going to mark that as complete. So now we're getting to, in our first part of doing revision, we're going to look at the Boolean. So the Bool data type is necessary for the evaluation of logical data, which is inherently different from the numerical or string data types introduced so far. Bool stands for Boolean data, which can only take one of two possible values, true or false. You should recall from the previous unit that true and false are reserved words within the Python language. Try executing these commands in the Replit Run window. So we've created a Boolean value for A, which is true. If we print type A, we should get bool. So let's insert that here and see what our output is. In fact, I think we should delete all of this so that we don't keep running that code. So you see here, A is true and the class is bool. You should see that true and false appear in your program as blue text, indicating that they are reserved Python words. It didn't. Oh yeah, it did. It is blue. It might be difficult for you to see. And I'm also going to zoom in so it's hopefully easier for you guys. And I could even hide that window there, that sidebar. So true here is it's in a very faded blue, which means that it's a reserved Python word. Furthermore, the data type should be identified as bool. Let's investigate how this data type can be used. Relational operators are those that compare values in order to determine their relationship. Here is a short list of very useful relational operators. So we have equals equals, we have not equals, greater than, smaller than equal, or greater than equal. And you can use this to evaluate the relationship between different data types or different values. So if you want to check if a number is bigger than another number, you would use these operators. It should be clear why these are called relational operators. Also note that the only possible answers when using these operators are either true or false. Be extremely careful to never confuse the assignment operator, which is one equal, with the relational equals operator, so two equal signs. They serve two totally different purposes. Copy and paste this set of commands. So let's delete that and we're going to run the code. So when we print A, we get 5. Why is that? Because we said A equals B and B is basically 5. Now over here we've got A is 2 and B is 5. So we use equal equal to see if they are the same. Let's see if we put one equal sign. So that's why the answer is false, because 2 and 5 are not equal. You see here it says it will give us a type error. A is an invalid keyword arrangement for print. So if you ever want to check if two things or two values are the same, you must use equal equal. The assignment operator assigns the numerical value contained in the variable B to the variable A. The relational operator compares the variables A and B for equality, which evaluates to the bool data type false. Finally, there are logical operators that allow us to form combinations of logical expressions. You should understand these definitions for logical operators given two Boolean variables x and y. So if we say not x, then the logical component, if x is true, not x is false. If x is false, not x is true. So it basically inverts. So if x was previously true, by putting not in front, you're making it false. X and y can only be true if both x and y are true. Otherwise, it will be false. And if we say x or y, it can be false if both x and y are false. Otherwise, it evaluates to true. So when we're looking at and, they both have to be true. If they're not both true, then you will get a false output. With regard to or, one of them can be true. X or y can be true. So you will get a true Boolean value. But if both of them are false, then it won't be true. So for the or logical operator, it's sufficient if only one of them is true. These operators will be incredibly important in the next unit. For now, we just need to practice using them in order to get used to the syntax. So I just want to check here. So I'm going to play this video. that example explains it quite nicely. We are going to mark this section as complete. So now we are going to look at, well, I just want to see, just want to make sure we haven't missed anything. It's all good. So understanding Boolean logic. The Boolean data type can be one of two values, either true or false. We use Booleans in programming to make comparisons and to control the flow of the program. Booleans represent the truth values that are associated with the logic branch of mathematics, which informs which informs algorithms in computer science. Named for the mathematician George Boole, the word Boolean always begins with a capitalized B. The values true and false will also always be with a capital T and F respectively, as they are special values in Python. So remember, generally the convention is in Python is that we use lowercase. So this is an exception. In programming, comparison operators are used to compare values and evaluate down to a single Boolean value of either true or false. So we have discussed these. Equal to is two equal signs. Not equal to is an exclamation mark equal. The less than, greater than symbols. And of course, less than and greater than can also include the equal sign, meaning it's less than or equal to. To understand how these operators work, let's assign two integers to two variables in a Python program. So we're going to say x equals 5 and y equals 8. We know that in this example, since x has the value of 5, it is less than y, which has a value of 8. Using these two variables and their associated values, let's go through the operators from the table above. In our program, we'll ask Python to print out whether each comparison operator evaluates to true or false. To help us and other humans better understand this output, we'll have Python also print a string to show us what it's evaluating. So let's copy and paste this and run our code. So x equals y is false. X not equals y is true. X smaller than y is true, but x greater than y is false. X smaller than or equal to y is true. So remember, it can be or, equal than or equal. So it's true because it's smaller than. Doesn't have to be, it's not equal, less than, and equal. Okay. X greater than equal y is false. It also says here, although we used integers here, we could substitute them with float values. Strings can also be used with Boolean operators. They are case sensitive unless you employ an additional string method. So remember, Sammy and this Sammy are not going to be equal because the one Sammy uses a capital S, and that's why it's false. They are not exactly the same. One starts with an uppercase s and the other with a lowercase s. But if we add another variable that is assigned the value of Sammy, then they will evaluate to equal. Sorry, Sammy. Yeah, so again, this is going to be false, but these two are going to be equal or true because they both start with a capital S. You can also use the other comparison operators, including greater than and less than, to compare two strings. Python will compare these strings lexicographically using the ASCII values of the characters. You can also evaluate Boolean values with comparison operators. So print T not equal F. That is true because true is not the same as false. So they're not equal. The above code block evaluated that true is not equal to false. Note the difference between the two operators equal and equal equal. And we know that because the first is the assignment operator. The equal equal is a comparison operator. There are three logical operators that are used to compare values. They evaluate expressions down to Boolean values, returning either true or false. These operators are and, or, and not. So we've looked at arithmetic operators, we've looked at comparison operators, and then we have three logical operators, which is basically and, or, not. Remember, in the case of and, both have to be true. In the case of or, only one of them has to be true for the statement to be true. Not means true only if false. Logical operators are typically used to evaluate whether two or more expressions are true or not true. For example, they can be used to determine if the grade is passing and that the student is registered in the course. And if both cases are true, then the student will be assigned a grade in the system. Another example would be to determine whether a user is a valid active customer of an online shop based on whether they have store credit or have made a purchase in the past 6 months. So in that last example, only one of them has to be true. To understand how logical operators work, let's evaluate three expressions. So 9 is greater than 7 is true, and 2 less than 4 is also true. So we use and our output will be true. 8 equals 8 is true. 6 not equals 6 is false. Because it's or, meaning only one of these has to be true, the output will be true. Then we have 3 is smaller than or equal to 1, which is true, and then we're saying, sorry, 3 is bigger, so it would be false. So the output will be true because the original expression was false. It basically inverts it. And they're basically just explaining what I've explained. You can also write compound statements using and, or, and not. Let's look at the innermost expression. So we're looking at this example here. 0.8 smaller than 3.1 or 0.1 equals 0.1. This expression evaluates true because both mathematical statements are true. Now we can take the returned value true and combine it with the next inner question, which is negative 0.2 is greater than 1.4 and true. This example returns false because 0.2 is not bigger than 1.4. And so false and true together return false. Finally, we have the outer expression not false, which, this is the notch here, evaluates true. Because our final answer was false, or not final, but we got false, and now we just invert it. So also remember to look at the brackets. Not is done last because everything here within the not bracket has to be done first. And within this statement, there's another set of brackets, which is this one here. That's why this is done first, then this, and then the not. So when this resulted in an output of false, it became true. The logical operators and, or, and not evaluate expressions and return Boolean values. So we're going to look over here at some truth tables. There is a lot to learn about the logic branch of mathematics, but we can selectively learn some of it to improve our algorithmic thinking when programming. Below are truth tables for the comparison operator equal equal, and each of the logic operators and, or, and not. While you may be able to reason them out, it can also be helpful to work to memorize them, as that can make your programming decision-making process quicker. So the way I remember it, when we're looking at the equal equal, if they are true is equal to true, so if they're both true, then the output is true. If one of them is not equal, the output will be false. And this applies in both these cases here because one of them is not. And if they're both false, it will be true. With the and truth table, they both need to be true, and that's the only time you will yield a true result. If one of them is false or both are false, the output will be false. With or, one of them has to be true. So in that case, there's true, 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 meaning all of these will be true. And so where there's no true statement, then it will be false. And basically with the not truth table, if it is not true, it becomes false. And if it's false, it becomes true. Using Boolean operators for flow control. To control the stream and outcomes of a program in the form of flow control statements, we use a condition followed by a clause. A condition evaluates down to a Boolean value of true or false, presenting a point where a decision is made in the program. That is, a condition would tell us if something evaluates to true or false. The clause is the block of code that follows the condition and dictates the outcome of the program. That is the to-do list part of the construction. In other words, to put that in very simple terms, if X is true, then do this. The code block below shows an example of comparison operators working in tandem with conditional statements to control the flow of a Python program. So if grade is greater than or equal to 65, then it will print passing grade. Else, it will print the failing grade. In other words, if you got less than 65, you failed. This program will evaluate whether each student's grade is passing or failing. In the case of a student with a grade of 83, the first statement will evaluate to true, and the print statement of passing grade will be triggered. In the case of a student with a grade of 59, the first statement will evaluate to false. So the program will move on to execute the print statement tied to the else expression, failing grade. Because every single object in Python can be evaluated to true or false, the PEP 8 style guide recommends against comparing a value to true or false because it is less readable and will frequently return an unexpected Boolean. That is, you should avoid using if Sammy equal true in your programs. Instead, compare Sammy to another non-Boolean value that will return a Boolean. So in other words, we shouldn't say Sammy equals true. You always want to compare Sammy or one variable against another variable, but not a variable that's a Boolean value. And remember, there's only two Boolean values, true and false. Boolean operators present conditions that can be used to decide the eventual outcome of a program through flow control statements. So flow control statements is basically if else. And we even did elif. Conclusion. This tutorial went through comparison and logical operators belonging to the Boolean type, as well as truth tables and using Booleans for program flow control. You can learn more about other data types in our Understanding Data Types tutorial and can read about conditional statements in our How to Write Conditional Statements tutorial. So we are going to mark that as completed. And then we are going to look at 2.4. I think this is the last unit or the last chapter for this unit. So if we look some more here on operators and expressions, most statements, which are logical lines that you write, will contain expressions. A simple example of an expression is 2 plus 3. An expression can be broken down into operators and operands. So remember, operands are like our arithmetic operators or the other operators we've learned about. Operators. Operators are your pluses, your minuses, all these things we've learned about, and then your operands are like in this example 2 and 3. So operators are functionality that do something and can be represented by symbols such as plus or by special keywords. I presume in this case like and or other logical operators. And operators require some data to operate on, and that data is called operands. We will briefly take a look at operators and their usage. Note that you can evaluate the expressions given in the examples using the interpreter interactively. For example, to test the expression 2 plus 3, use the interactive Python interpreter prompt. That's basically what we are doing here in the console. We have plus, minus, multiply, to the power, divide. So this looks like a revision of what we've already covered. I see here though we have some others. So we have left shift. So this shifts the bits of the number to the left by the number of bits specified. Each number is represented in memory by bits or binary digits 0 and 1. So remember, a bit is basically a 0 and a 1. And we learned in our previous videos that a byte is 8 bits. So 2 left shifted by 2 gives 8. 2 is represented by 10 bits, by 10 in bits. Left shifting by 2 bits gives 1000, which represents the decimal 8. So I just want to see 2, 4, 6, 8. Maybe it's because each digit here is effectively, I don't know, 2 bits? No. Let's just look at right shift. Shift the bits of the number to the right by the number of the bits specified. So we're going to do 1 bit gives 5. 11 is represented in bits by 1011, which when right shifted by 1 bit gives 101, which is the decimal 5. We also have AND, bitwise AND of the numbers. If both bits are 1, the result is 1, otherwise it's 0. 5 and 3 gives 1. And then we have OR, which looks like that. It's a straight line down. Bitwise OR of the number. If both bits are 0, the result is 0. Otherwise, it's 1. Then we have bitwise XOR and bitwise inverse. We have the less than, greater than, less than or equal to, greater than or equal to, equal to, not equals to, and then we have our Boolean operators, which is not, and or, as we've covered. It is common to run a math operation on a variable and then assign the result of the operation back to the variable. Hence, there is a shortcut for such expressions. So instead of writing 2 by 3, we can just say A times 3. Or we can say A equals 2, A times equal 3. Which means we basically take A and we times it by 3. And we learned that this is useful, especially when we want to repeat something. For example, in a loop. If you had an expression such as 2 plus 3 times 4, is the addition done first or the multiplication? So we know that the multiplication would be done first. Our high school math tells us that the multiplication should be done first. This means that the multiplication operator has higher precedence than the addition operator. The following table gives the precedence table for Python, from the lowest precedence to the highest precedence. This means that in a given expression, Python will evaluate the operators and expressions lower in the table before the ones listed higher in the table. The following table, taken from the Python reference manual, is provided for the sake of completeness. It is far better to use parentheses to group operators and operands appropriately in order to explicitly specify precedence. This makes the program more readable, so make note of that. So these at the bottom have a higher precedence. It says here, the following table gives a precedence table for Python from the lowest to the highest. Python will evaluate the operators and expressions lower in the table, and otherwise these ones, before the ones listed higher in the table. So we've got here our exponents. But as they say, the convention is to use brackets because that also makes the code easier to read. The operators which we have not already come across will be explained in later chapters. Operators with the same precedence, for example, multiplication and division, or subtraction and addition, they have the same precedence, and those you could just normally read from left to right. To make the expressions more readable, we can use parentheses. For example, writing 2 plus and then 3 times 4 in brackets. It's definitely easier to understand than 2 plus 3 times 4, which requires knowledge of the operator precedences. As with everything else, the parentheses should be used reasonably. Do not overdo it, and it should not be redundant. Like this is redundant. We don't need these outer brackets here. There is an additional advantage to using parentheses. It helps us to change the order of evaluation. For example, if you want addition to be evaluated before the multiplication, then you just use the brackets over the addition sum. Operators are usually associated from left to right. This means that operators with the same precedence are evaluated in a left to right manner. For example, 2 plus 3 plus 4 is evaluated as, basically from left to right, we would calculate 2 plus 3 first and then plus 4. So we have length and breadth, which are two variables assigned two values. To calculate the area, we would say length times breadth, and then we can print a string. The length and breadth of the rectangle are stored in variables by the same name. We use these to calculate the area and perimeter of the rectangle with the help of expressions. So remember, these are our expression, like this is an expression, length times breadth. We store the result of the expression length times breadth in the variable area and then print it using the print function. In the second case, we directly use the value of the expression, 2 times length plus breadth, in the print function. Also notice how Python pretty prints the output. Even though we have not specified a space between area is and the variable area, Python puts it for us so that we get a nice clean output and the program is much more readable this way, since we don't need to worry about spacing in the strings we use for output. This is an example of how Python makes life easy for a programmer. So we learned about %d and %s for basically inserting placeholders within a string. But you can, like they just explained here, if you just put a comma and then area, which is this expression over here, then it will print it, and it will print it with the space. So I didn't know Python could do that. We have seen how to use operators, operands, and expressions. So we should know now quite well about those three. These are the basic building blocks of any program. Now we will see how to make use of these in our programs using statements. So we can mark that as completed. There is a study session video review. It's about an hour long. If you're feeling like you're not understanding or you try the assessment but maybe you don't do well, then it's probably a good idea to watch it. There's also a review here. And that's it. That means there's only the assessment to do. I will then, in that case, see you guys for Unit 3. I hope you guys have a blessed day wherever you are. For me, it's the weekend now ahead, but I'll be back on Monday with a new video and to start with Unit 3. God bless.